Hello. Thank you for joining us for today's Caringo Tech Tuesday webinar. This session's topic is cloud seeding with object storage containers. I'm Ryan Meek, Principal Solutions Architect at Caringo. Before we get going, let's go over some operational details. We've loaded useful resources you will find in the attachments and links box on the right-hand side of your screen. There's also a question field. Please feel free to ask questions throughout the webcast or save them for Q&A at the end. You can also email us at info@caringo.com if you prefer. So I'm Ryan Meek. I've had roles at Caringo including development, technical account management, and technical sales starting in 2006 with Swarm version 1 beta 1. So now I'm Caringo's Principal Solutions Architect and happy to be here with you today. Our guest expert is Jamshid Afshar. Jam, why don't you introduce yourself?
Thank you, Ryan. I've been with Caringo since 2010, and in that time I've worked on Swarm, Gateway, and a little bit of UI. I've also been a senior consultant, helping with many of our large profile customers. I'm back in engineering, where I'm leading our efforts around containers.
Excellent. Yeah, and for everyone's information, Jam is sort of our go-to guy for all things container. He's been really an evangelist for the movement to containers over the years. And so, yeah, we're super happy to have him with us. A little more about Caringo. So we were founded in 2005 to change the economics of data storage by enabling really relentless data growth, especially with object. Today, our products are market hardened at version 11 and are used across many industries, including organizations such as Department of Defense, Department of Justice, NIH, Argonne National Labs at the Department of Energy, world-class telecoms like British Telecom, video streaming at places like NEP, and other countries' federal court systems like the Brazil federal court systems, many more worldwide. So why don't we send it over to Jamshid? Why don't you take us away?
Sure, thanks, Ryan. All right, so the agenda for today is we're going to discuss why we want to use containers. We're going to show some use cases for containerized object storage. And then we're going to demonstrate bringing up an environment and doing a stateless container image registry and pushing a sample image to that registry. All right, and all right, so why containers? Well, we have virtual machines, and that's how things are commonly deployed, but they have the golden image problem, meaning that once you build an image, it's harder to upgrade it and to deploy like different pieces that have been upgraded. That's especially common that's especially common with the microservice architecture. But I bet even if you aren't using a full-blown microservices architecture, you have a lot of services that need to be updated that have dependencies between them. And doing that with VMs can be difficult. Containers are also lightweight. They share the Linux kernel, so they don't each have a copy of an OS running in them. Containers solve the dependency management problem by simply keeping each of the containers independent of the other. So even though they're sharing the same Linux kernel, they're not sharing things like, shared libraries. You don't have to worry about Python dependencies trampling over each other. A really great thing about containers is that they provide a clean separation between the code, the things that you execute, versus the configuration and versus the data that you want preserved. As I had mentioned, the containers allow for multiple services to be deployed and updated independently. And all of this is part of the general IT push towards immutable infrastructure. You might have heard that referred to as cattle versus pets. The idea being that pets are cared for when they get sick, when they're broken, you nurse them back to health, and you scale them vertically to scale up. And the problem with them is that when they go down, everybody notices. Now this is versus cattle, where they're almost all identical to each other. So when one gets sick, you just replace it with another one. Scaling is done horizontally, so that if one is unavailable, it's not as noticeable. Containers, and actually the first reason I started using containers is for consistency throughout the product lifecycle. For things like having a developer environment all on your laptop, for doing integration testing. These are all the reasons you would want to use containers. So here are some use cases for containerized object storage. As I mentioned, one of the first reasons to use containers that became popular was for laptop environments, for development, integration testing, and sales demos. Ryan, can you talk a little bit about the other use cases?
Yeah, so we started seeing these pop up, especially recently, in a mobile environment. So for instance, with a mobile hospital, like a mobile Army hospital or mobile Navy hospital, and regional health systems, regional health management, or even inside ambulances. It's really nice to be able to run a fully featured object storage cluster, but be mobile and not have to have a full rack of metal along with you. That way you get the data protection, you get things like the UUIDs, the named objects, and the applications themselves, maybe image production systems or DICOM systems, can actually offload the image to object storage. And then once the ambulance or mobile hospital is in range of its base or its hospital, then it can sync its objects with the the mothership, if you will. So it just really enabled some interesting use cases in medical. It also turns out to be a great way to run a fully featured stack in a public cloud. So one of the things that we're seeing, just sort of as a result of our our challenging times, is customers are moving their dev systems or their QA systems in a lot of cases to public clouds. So maybe their worldwide distributed teams will be logging in to a public cloud and doing their work there. So it's actually really nice to have a fully featured stack, a fully featured swarm stack in sort of the public cloud of your choice. And of course, sort of the same thing goes with sources for telemetry. So we've at the edge for IoT. So we've seen use cases like drones copying videos back to their base stations in locations that may or may not have internet access. So it's really just a lot of modern use cases, and a lot of places where it's nice not to have to bring a rack of metal with you.
Yeah, that's right. All these cases are just growing and growing. Okay.
Absolutely.
All right. Now we're going to enter the demo part of our presentation. So you should now see my screen. Is that do you see this, Ryan?
Yep, we see it
with the Docker run command?
Yeah, we
Great.
see it.
Okay.
We see it perfectly, and we can even read the text.
Perfect. All right. Then this is what you run to start up a containerized Caringo environment. All this requires is like a MacBook or Windows PC with Docker for desktop installed, or of course you can run it on Linux. Just install the Docker C-CE packages. There's plenty of instructions at docker.com. All right, let's kick this off. So it starts churning away here. You can see all the services that it brings up. There will be a Grafana for dashboard for watching the metrics, along with, of course, the actual swarm containers and gateway and Elasticsearch. So hopefully this is familiar to you if you've been through Caringo training for bringing up the environment. But the nice thing about this is that it's all auto-configured. You don't have to do anything. You don't have to edit config files or anything. And this uses, by default, just loopback files rather than actual physical drives for the storage. So it's just suitable for testing and for laptop environments, but it could also be used, it can also be used with real physical drives. You just have to configure that. So now it's at the stage where it is verifying that Elasticsearch has come up and it's running. This is only a single node Elasticsearch for data. Since it's all running in one laptop, there's not much reason to have multiple. Okay, now we're configuring Prometheus and Grafana. These are the dashboards that we introduced last year for monitoring our stack. And we'll see that later on when it comes up. Normally I would be nervous because of this pause, but I've been through this enough and I know it takes a little while. All right, now we're verifying that Swarm is up. All the nodes can see each other. We created an Elasticsearch search feed in Swarm. So that's what provides our object listings. The script does a lot of sanity checks to make sure that, okay, Elasticsearch is still up and healthy. All right, now we're nearing the end, initializing the gateway and starting it up. It will then create a sample tenant and domain. It's called backup 42 is what our domain will be. All right. Now we're ending with the creation of the S3 token, which we'll use to configure an S3 client. Okay, so here's a summary of all the services that are provided in this environment. So you can see you even have things like HA proxy for SSL offloading that sits in front of your gateway. You can see, and let me just show you, it also comes with an LDAP, with a test LDAP server. So you can log in. All right. Let's log into our environment. First, let's go to the content portal. This is the console that you use to see the objects, the domain, the bucket, and any objects that are there. Why don't we go ahead and upload a file just to make sure this is all working. And I sure like the cats ringing for dinner. Let's do that. There we go. Isn't that cute? All right.
That is great. And we can also notice those file creation times are UTC, but they're right now. So you can see that file was just created.
Right, good point. These are, this is no magic going on behind the scenes. This is really live. Okay, we'll look at the storage console now. Now this is what Swarm administrators go to see, to verify it's healthy, to check the disk space usage. Of course, we don't have anything being used yet. Here are the nodes, the 3 nodes. These are all containers running inside on this same laptop. And you can see the search feed here. And that's good and healthy. Of course, this is the Swarm console is where you go to edit the cluster settings, do things like change the log level. And yeah, some of the metrics are not yet available, but they'll be coming up soon. All right. Sec. So this is the Docker application. Here's the environment. It's called Caringo 42. And you can see all the containers here are running. One thing I really like to do, just as to whenever you're monitoring a Swarm cluster, is to go to the to watch a log. It's very handy to verify that your requests are coming into the gateway. That's where S3 applications and your the administration consoles are located. All right, let's now go to Visual Studio. This is Microsoft's Visual Studio for Visual Studio Code, it's called. Sorry, 1 second. So something they introduced in about the last year or so is a very nice Docker integration. So I definitely recommend checking this out. You can see here where it shows your containers that are running. It shows the images that are up. And we'll talk a little bit more about images, and we'll show an example of how to create one. Okay. All right, so I've been talking about images. Remember I said that container images are sort of like a virtual machine template. So this is what it looks like. This is what's called a Docker file. It's used to build the image. And you can kind of think of it as a script that you start from scratch. We start from just a base CentOS 8 OS. And then we do the things that are required for this tool that I'm going to install, just doing some yum installs. And this, what I'm going to demo is a Docker image that contains our support bundle, our support tools. These are just tools that we've been using over the years to access extra information about your Swarm cluster. And it was just an example of something that's a way to create a small, simple Docker image. Each run command is just run sequentially when you do a build. And let's look at that. To open. Sorry, just 1 second. I'm not seeing the thing I expected to see. That's okay. We'll build it by hand. Okay. So this is a command to build the Docker file and to produce an image. The image will be named this. And that's all there is to it. Oh, I had it cached. All right. Now, so now we have this image. Let's use it. Now what I'm going to do is connect up to the Caringo environment that I brought up. So that's what this network command does. This says, because each time you bring up an environment, it's actually running in its own network. All the containers have their own IPs in a private network space. You can, of course, expose ports. That's how we get to the Swarm console. All right, so this Docker run is starting up a bash shell. And we have access. One of the commands is a newer command called swarm control. It is very handy. It shows us kind of everything there is in a swarm cluster, and it's a nice command line tool. If you have a support ticket, they'll probably have you run it for something. So we're going to point at the swarm nodes and just get a quick summary of everything that's running. This is kind of the same thing you would see in the console, but it's from a command line. Okay, so that's the support tools. So we have this image. Now I want to show you how you can save that image to what's called a Docker registry. A Docker registry is where you store images so that they can be downloaded by others. Now, a very cool thing you can do is, normally by default it stores the images on the files in a file system, but it's a lot better to store it in object storage, because then your containers become stateless. And that's very important because that means you don't have to worry about saving the data if the container goes away or losing the data. And it greatly simplifies your container management and deployments. So just remember that. And what's cool is a lot of tools are going towards this approach, where things are preserved within, for example, an S3 compatible storage layer, rather than being preserved in a file system. Okay, so this is, let me bring this up. All right, this is what's called a Docker Compose file. Docker Compose is a utility that is provided by Docker to effectively run containers, but keep the configuration all together. So let's walk through what each of these pieces are. So this is the name of the service. This is the image. That's something that's provided by Docker. You can see you can do things like restrict the memory usage. Now there's nothing, you don't have to use Compose, because all of this just translates to options on the Docker run command. There are some HTTPS certificates that are saved. A Docker registry is really just an HTTP server that it has a special API that the Docker command uses for pushing and pulling images. It has access to the to the swarm environment that we just brought up, and that's where it's all configured here. You can see some of these settings are inside of what's called a .env file. So, and I'll actually have to replace this because this is a new environment. That is the S3 I could also just create a new S3 key, but since I already have one, I know inside of my config, I'll just reuse that one. And actually, let's go ahead and create a different, let's put it in a different bucket. And we'll create that bucket within the Swarm console. All right. There's the registry bucket that I just created. And now we will bring up this environment. All right. That's really all there is to that. Now, what we're going to do, we might be able to start seeing some activity from the registry just so that we can verify that it really is talking to our Swarm environment. So I have this image. You can see it here. Now what I'm going to do is first remove the old one that I had. All right. Now I'm going to tag the image, and this is the way you push an image to a registry. It's running on port 5000. And I'll just name it the same way. All right, that just tags it. Now I have to push it. So there you can see it's going through the registry, and the registry is just writing it out to Swarm. Takes a little while at the end to complete. Yep, there it goes. All right, we have the registry now pushed. Now I'm going to remove the images. We'll pretend that this is a brand new system or a system on a different machine. I still had a container using it. Sorry, I had a dead container, still using it. All right, Docker, are you going to let me delete that? Yes. Okay, so we have no images up our sleeve. Let's now see if we're still able to run it. I'm going to run it from the registry, so it automatically does a pull from the registry to pull down the support tools image. And there you can see it is fetching it from here. And it is already downloaded. By the way, a cool thing about the way the Docker registry works, just an implementation detail, is that it will actually redirect the Docker client to Swarm itself. It uses a signed URL so that when Docker is downloading, like the parts of the image, the layers of the image, which are basically tarballs, it will actually be downloading that directly from Swarm, not going through the registry service. So I thought that's kind of cool. Seems very efficient. All right, and we're in the same place we were before. We can run Swarm cuddle to get a sample or to get a listing of this.
It's great. And you can actually see where those objects are taking up capacity in this cluster.
Right. Since we've added some more objects.
Mm-hmm.
Oh, now one thing I didn't run, I'll do it right now. I didn't run test S3. Did I run test S3 clients? Maybe I did. Yes. No, I did not. All right, so we had mentioned one of the use cases is integration testing. So let's do that now. Oh, and let's do that via the Docker UI. You can always do everything with Docker from the command line, but for example, Visual Studio Code or the Docker application itself provides some UI help for that if you prefer. So let's go into the test container. And what that does is starts up what's effectively an SSH into a container. That's what a Docker exec is. So I'm inside of the environment. For example, I can see where the Swarm nodes are. Those are the IPs of the Swarm nodes. And let's run, and just leave this running, a simple script we use for testing a variety of S3 command line clients, just to verify compatibility. So we will leave that running. We can see the activity inside of both the logs here, but also, even better, we can see it inside of Grafana. So these are the dashboards we were talking about that show everything that is that shows stats for both our Swarm, Gateway, and Elasticsearch services. Right here you can see this is the activity that we've been doing now. This only started like a half hour ago. We also have the Swarm statistics. See all our nodes, our 3 nodes. See the operations that are happening right now due to that test. And you can also monitor Elasticsearch. You can see
and
where,
just so everyone's aware here too, these dashboards are actually publicly available and modifiable in case you want to use them as a starting place and create your own DevOps dashboards or make your own visualizations.
Yeah, that is very nice. It's really the reason I think Grafana has become so popular is it's so easy to take a dashboard and just start updating it with what kind of information you need to see. see. Our test is still going. Oh, it's that window. And these are pretty cool tests, I think, because they do things like mount a virtual directory that's backed by our swarm. Doing some deep nested directory listing.
So not only setting up a swarm cluster and showing it working with containers, but also automated integration testing and Graph-on dashboard visualizations for a bonus. Not bad, Joe.
Thank you. Yeah, it's very cool. I think that you can get this much out of automation. You know,
we don't want to do all that work every time, right?
Exactly. And you know that's the whole reason for automation is that people just won't. If it takes that much, if you have to configure things by hand, your organization is going to choose not to do that. So it's very limiting. All right. Well, that's still running. A quick shout out to 12factor.net. That has some, it came out around the same time as I guess containers became popular, and there's a lot of compatibility there. The whole idea of deploying environments declaratively and with automation versus doing things by hand. The idea of your deployments being portable across different environments, across development, QA, production, that it can be deployed across cloud platforms. And this is all getting back to minimizing the divergence between development and production. You know, it works for me, why doesn't it work for you problem. Just a quick note on cattle versus pets. As I mentioned, this is the idea behind it. That I like this quote that I saw on a blog, where pets are nursed back to health, cattle are replaced.
It's kind of cold-blooded, actually, right?
It is cold-blooded, yeah. But it's true. People love their pets. But maintaining systems, it's kind of funny that after all the work that the IT industry and OS developers have put into package management, there is a bit of throwing in the towel with immutable infrastructure, and that we don't keep, there's no reason really to keep servers through OS upgrades. And things that used to be such a badge of honor are like, oh, this server has an uptime of 2 years, are now seen as problematic, because it's like, well, what happens if it crashes? Are you unable to bring it back up automatically?
Right. It's that same kind of perspective where if you need heroic effort to get a release out, you're on the wrong path. It should be a less dramatic march towards a predictable release.
Oh yeah, very good point. And actually, the Caringo Alpha image that we use to deploy this is kind of an example of that, in that it's totally automated, where it's able to pick up the new release candidates and new alphas very quickly and easily. It's not like you have to have a human being making a release. All right, so we can see that the environment all came up very nicely. We can see that that's reflected in our monitoring here. We can see all the buckets that got created by this test. And the usage. All right.
That's nice to see.
Yeah. And then the only other thing that might be interesting to see, and it won't finish probably before the time is up, but something I think is very cool is we've seen how to push that support tools image to our registry, but you can actually push even all the images that we just deployed to our registry. Yeah, here we go. I have a little script called push.sh. It just takes all the current images and then you pass in what registry you want to push it to. So this takes a while because there's it's a few gigs. But you can see it being pushed, and we can see it inside the content portal, inside our registry bucket. We see all these blobs. These are the different layers of the images. And I think that's pretty neat, that the idea that you can, bring up a swarm and then pretty much store the swarm binaries, the swarm executable back in Swarm itself. And now you could even deploy it from this swarm. So it's kind of a self-replicating thing, a virus. It's kind of nice.
Yeah, that is very nice. Well, that's good to see, Jim. I mean, it's a swarm demo. It's a visualization demo. It's a containerization demo, and then we even got into our internal dev practices and integration automation.
Yeah. Well, that's I think that's all I really had to demo. This is just going to continue going on, but I do have, actually I even took a little picture of it. How did I think about it? There, about desktop. Yeah, this was just showing how all the images are loaded up into the registry.
Excellent.
Let's see, the only other things I wanted to mention are some recommended videos. There was a recent DockerCon that was all online, and you can go there and see some videos, and I really liked these for, in particular, just a general introduction to Docker and Kubernetes. There was one that I guess I need to run again because I did not, for some reason, the Visual Studio Code hookup wasn't working, but it's a very nice thing that Microsoft has done here, where you can see, actually you can already see it right now, you can see the registry the registry here and what images it has loaded.
Very nice.
You can see what networks you have in your environment and the volumes. That's where things are, the permanent sort of data is all there, and what running containers you have. So it's similar to like the Docker UI that you can see here.
It doesn't make me want to spend my entire day inside Visual Studio like I used to, but I'm sure that is super useful if that is your task.
Yeah. It's actually as someone who didn't really come from the Microsoft world, I've been pretty impressed with Visual Studio.
They're better than they used to be.
Yeah, definitely. I'm sorry. And then there's a Docker Compose video and Kubernetes video that goes into it's kind of a deep dive into the kind of networking problems you would have in Kubernetes. And we've shown an example of how to use a registry backed with Swarm, but there's a bunch of other ways that you can use Swarm with containers. For example, with Elasticsearch, and we have this documented in our docs, is how to use Swarm as a backup for Elasticsearch. Now, of course, you shouldn't back up your Elasticsearch to the same Swarm server that is using it, but it actually does work. Even the restore does work. And there's some really exciting new tools coming out that take this sort of object storage first approach to storage, where instead of having to have a database that it uses to store things, it actually just stores things in an object storage in an S3 compatible system. So that's very neat stuff that's coming out. All right, Ryan,
Very cool.
I will hand it back to you while it continues pushing all these images.
Okay, perfect. So I will go ahead and take control back with the slides.
Yes.
So why don't you summarize for us before we exit here?
Sure. So as I was saying, containers, the whole idea behind them is that they simplify deployments across environments. I think everybody can get use out of their IT practices. Practices can be improved by the way they separate out the code, configuration, and data, because that's something that's the cause of a lot of our IT woes. And then the reason object storage is important for containers is that it allows you to run stateless containers that do not require a data volume to preserve things. It's all just preserved within object storage. So, for example, when I delete the registry that I created, it is just a matter of bringing it back up and pointing it at the same swarm bucket. And I'm right back to where I started from.
Excellent.
And, yeah. So let me advance over. And by the way, have there been any questions from the audience about any of that demo? I know I didn't get into too much about Docker basics, but I figured there
was one question that I wanted to highlight before we get out, and that was, how have you, or how early did you start using containers in your own development?
I was pretty early on. I think 14 or 15 when Docker, which started out as a different company. I think they were some kind of cloud provider. But yeah, it feels like forever, but I guess it's only been like 5 years maybe.
And then I think I remember seeing you demo it. Probably as early as 16 or 17, right? You were actually introducing it into the back end IT flow pretty early.
Yeah. Yes, it was all just scratching an itch. It was I needed to be able to test things like gateways when there are multiple gateways behind an HA proxy, and that's the kind of stuff that's really cumbersome to set up for in a real environment, because you have to go around to different machines and install them all, and you have to reserve those machines. And if you're just doing some like functional testing as opposed to say performance testing or getting benchmarking, this works great. You can run 3 gateways on the same machine, and you get the tests that you need. And that was definitely very helpful, because it did simplify testing and allowed me to run a lot more tests than I would have been able to otherwise. Yep.
Yeah. Well, thank you very much, Jamshid. We've gotten a lot of questions about containerization, and I think this really covers it. This is all the way from sort of development and DevOps to how we can use it in production and the different use cases. So I think it's a fairly comprehensive treatment so far. And if everyone would like additional questions or a follow-up set of content, reach out to us and let us know. We'll be here. Before we go, I would like to invite everyone to join us for our upcoming events. This Thursday, June 25th, Brews and Bytes webcast episode 7 is Distributed Collaborators and Data, Solving the World's Big Problems with Globus. And if you haven't caught this yet, this is hosted by AJ Herrera, our VP of marketing. It's a great series, very informal, kind of a roundtable format. And then July 28th, Tech Tuesday webinar providing NFS access to object storage using Swarm NFS. So I just wanted to make sure and highlight those. Before we exit, to keep up with Caringo, you can follow us on LinkedIn and Twitter. And if you have additional questions or would like to schedule a custom demo, please email us at info@caringo.com. Thank you everyone for joining us.